Okay, so we're going to be looking at a larger right triangle. We're going to call this EDG, and we're going to drop an altitude straight down from the right angle. So we've got a 90-degree or perpendicular lines there, and we're going to call this intersection F. Okay. And one good thing to know is the altitude coming out of the right angle creates three similar right triangles. And we can set up an extended similarity statement to say triangle EFD, this guy right here, is similar to triangle DFG, and both of those are similar to triangle EDG, the big one. If you look more closely at what I've written down for similarity statements, okay, EF is the short leg of this one right here. That one will always correspond to the altitude DF, which is the short leg of that one here, which will correspond to ED, which is the short leg of the big one. Okay, so you could use the similarity statement to set up proportions to find missing segments in a diagram like this one. Okay. Now, if you are setting up or completing proportions, you're going to set up and complete the proportions in terms of short leg, long leg, and hypotenuse. For instance, you could say the short leg of triangle EFD over the long leg of triangle EFD should be in the same ratio as the short leg of triangle EDG over the long leg of triangle EDG. Okay, just like we've said in the past, if you're using or setting up the proportions, you want to be consistent with your proportions. If you're staying on the same shape, going short leg to long leg, then you would go to the other triangle and go short leg to long leg. Part of your work on this is just going to be completing proportions that they've started to set up for you. But the other part is going to be in a diagram like this. We should, with enough information, we should be able to find different lengths in that type of diagram. Okay. For example, basically. Latin, actually. It's an abbreviation for something Latin. All right. So we're going to do the same type of diagram with the big right triangle. We're going to drop an altitude out of that right angle again. But in this case, we're going to name our segments. Now don't get so caught up in the names because your triangles in your homework might have different letters than what you're seeing. What I want you to get, though, is the ideas. There are some shortcuts if you get used to what I'm going to have you write down. Okay, so we're going to call this A and B. So those are our two legs of our big right triangle. H is our altitude. C is the entire hypotenuse of the large triangle. And then X and Y are the two segments created by the altitude. And we're going to set up three proportions using this diagram. And we're going to show you how those turn into what can be used as a shortcut. The first proportion, we're going to say X is to A as A is to another length. And I'm not filling it in yet because I want you to look at what X and A represent. If I find X and A, those both happen to be on this little triangle on the left. So X appears to be the short, okay? With both of these, X and Y will not both be short. So as far as the little ones go, X corresponds to H on the other one. So we have short leg to hypotenuse, right? And then we have short leg on the big one. So what would complete the proportion? We have short leg is to hypotenuse as short leg of the big is to hypotenuse of the big, which is, what's the hypotenuse of the large right triangle? Hypotenuse is across from the right angle, C. C is the hypotenuse. So short leg is to hypotenuse as short leg is to hypotenuse, so C would complete that proportion. And if we cross multiply, we get A squared equals X times C, which is, this should appear to be a geometric mean. A is the geometric mean of X and C. And if you wanted to solve for A, taking the square roots of both sides, A would be the square root of X times C. Okay. Another, yep. They will be numbers, yep. Yep. In fact, you'll have some that are variables that you're looking for, and really you need all but one to be numbers in order to set up and solve. So if you have three amounts, two of them must be numbers or you can't really find out what your variable is. Okay, the next proportion we're going to look at is Y and B. And we're going to put C on the bottom of this one. And we're going to say Y is to B. Well, what is Y and B? Y would be what? Long leg, yes. The legs make up your right angle, so long leg and B is hypotenuse. So we have long leg over hypotenuse And C over here is the big hypotenuse. So B should go on top because that is the long leg of the large one. Okay. So again, we have another geometric means. So we'd say B squared equals Y times C. Or if you wanted just B, B would be the square root of Y times C.